So we use scientific notation to help us write either really large numbers or really small numbers, okay? You'll notice sometimes when you do things in your calculators, it will give you your answers in scientific notation because that number would either be way too large to fit in the screen of your calculator or way too small to fit in the screen of your calculator, okay? The formal explanation of scientific notation is that we take a positive real number and we write it in scientific notation using the form of that number C times 10 to some power. Okay? Some number C times 10 to a power. Whether that power is a positive or negative, it has to be a whole number. Okay? So it could be a positive whole number or a negative whole number. That's an integer. So it has to be an integer. And C has to be between 1 and 10. It cannot equal 10, but it has to be a number somewhere in between 1 and 10. And then I just gave you an example of scientific notation down at the bottom, the 2.25 times 10 to the fourth power. What we're going to do is I'm going to give you a number, okay, a decimal technically. Some of them are decimals, some of them are whole numbers, but there's still a decimal in whole numbers. And I'm going to ask you to write it in scientific notation. And then I'm going to give you numbers in scientific notation, and I'm going to ask you to write it as a decimal, and that's about as difficult as it's going to get today. Is everybody okay? Now, let me ask you this. Why do you think we use 10 to some power? If I multiply by 10 or 100 or 1,000, what does it technically do to my decimal? It just moves it. It either moves it forward or backwards, right, depending on what your power is that you're multiplying by. But the 10 just moves my decimal from place to place. Is everybody ready? Okay. Okay. Oops. Yeah. So we're going to take this large number and we are going to write it in scientific notation. So I want you to copy it down first. It's 3856, and then you've got 12 zeros behind it. I don't know. Okay. So it's hundred thousands, millions, billions, trillions, whatever comes after that, right? Just for the point. Yeah. Okay, so you have 3856 times, and then 12 zeros. All right, so if I want to write this in scientific notation, first of all, I need to figure out where is my decimal right now in that number. It's at the very end. It's behind that last zero, right? Okay. Now I want to move, try this one more time. I want to move that decimal to make my number in between 1 and 0. I always say move it behind the first non-zero digit. Okay, so what do you think I want to move it behind? What's my first non-zero digit when I read from left to right? The 3. So I want to move that decimal behind the 3. So what I have to do is figure out how many times I move that. Well, I'm just going to count, okay? I start here at my decimal, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my decimal now, my new number in between 1 and 10 is going to be 3.856. And it is times 10. Is it a positive 15 or a negative 15? It's going to be positive, okay? Now, you can try to remember the directions, but they kind of get backwards. If you're taking it and writing it in scientific notation, if you go to the left, you're going to use a positive exponent. If you go to the right, you're going to use a negative exponent. But that changes when we go in the other direction, so sometimes that gets a little confusing. What I like to think about is if I take that 3.856, am I trying to make it to a bigger number or a smaller number to equal what we started at? Bigger. That 3 whatever quadruple million whatever, I don't know how to say that number. Whatever that is a lot bigger than 3.856, right? So that tells me I want to use a positive exponent. Okay, because I'm making it into a larger number. If I were making it into a smaller number, I would want to use a negative exponent. That's kind of how I remember it. But if you want to remember your directions, okay. If I'm writing it in scientific notation, if I go to the left, we're going to use a positive exponent. If I move it to the right, we're going to use a negative exponent. Is everybody okay with that? Okay. And that's all we have to do. So if I'm looking at number 2, I've got 0.0000000. I can't remember how many I said. There's 5 zeros. And then 275. Where would I want to move my decimal this time? Behind the 2. Okay, so let's count how many times that is. Whoops. 1, 2, 3, 4, 5, 6. So my new number is 2.75, and it's times 10, but this time it's going to go to a small number, right? So what kind of exponent is that? Negative, yes. No. Do not count the 0 in front of the decimal. You just count how many times you move the decimal. Does that make sense? Everybody knows how to do this, hopefully? Kind of, somewhat, sort of. All right, try these two then. Where is my decimal right now before I change it? It's at the end. It's behind the last number. And where do I want to move it? Behind the 4. Okay, so we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to become 4.52 times 10. Is it a positive 9 or a negative 9? Positive, because my number is large. Yep. And then for number 4, where do I want to move my decimal? Behind it. 1, 2, 3, 4, 5, 6, 7. So it's 4.3 times 10 to the what kind of 7? Negative 7. Okay, this is not hard, right? These should be easy questions on our test for us not to have issues with. All right, and then we're just going to go the other direction. I'm going to give it to you in scientific notation, and I want you to write it. It says as a decimal. Remember, all whole numbers are technically decimals. We just don't usually write them. Okay, so try these two. You're just taking it from scientific and going into a decimal. If it is a positive, you go to the right. If it's a negative, you go to the left. That's why I don't like remembering the directions because they get confusing thinking about backwards. Bigger numbers are positive exponents. Smaller numbers are negative exponents. We learned that when we talked about the negative exponents the last few days. As long as the numbers aren't too terribly large or too terribly small, you could put 2.869 times 10 to the 5th in the calculator and it can tell you what the answer is. Unless I put like 20 on as an exponent, then it might not be, but that won't fit in the calculator. If I want to take 2.869 and I want to turn that into a decimal, how many times am I moving my decimal? 5. And which way do I go? To the right, making it bigger. So I'm going to go 1, 2, 3, 4, 5. And what do I fill in those empty spaces? Zeros. 0 is my placeholder. So that number looks really ugly. Turns into 2,869,00. So 286,900. Everybody okay with that one? All right. For 6, if I'm going to change this into a decimal, I need to move my decimal how many times this way? 3, and they're going which direction? To the left. We want to go smaller. 1, 2, 3. And again, I fill in all of my empty spaces with my placeholder of 0. So my new number is a 0.00103. You can put a 0 in front of that if you want to, but you also don't have to. Anybody have any questions? All right, try these last two real quick. For number 7, my number is 8.1. I want to move it 4 times which direction? To the right, because we're going bigger because it's positive. 1, 2, 3, 4. Fill in all of my zeros. And so I get 81,000 as my answer. Everybody okay with that one? Okay. And then if I have 3.7, oops, I'm not going to have space if I do it there. I want to move it how many times this way? 8, and I'm going left. If I'm moving it 8 spaces and there's only one number in front of the decimal, how many zeros am I going to end up with? 7, yeah. 1, 2, 3, 4, 5, 6, 7, 8, which lets me fill in 1, 2, 3, 4, 5, 6, 7 zeros. So, 2, 3, my new number is going to be that decimal. Anybody have any questions?